students, today we are going to see some more important questions. In one among that, hydrozones of acetaldehyde are not prepared in highly acidic medium. Explain. Okay, now directly which way they are asking. So acetaldehyde, hydrozones of acetaldehyde can be prepared in that weakly acidic medium. Why? So this kind of question also you can expect. Okay, generally hydrozones, how do we prepare? Aldehydes. This is a aldehyde functional group. This is a ketone functional group, isn't it? This is a ketone functional group combined with the hydrogen H2N, NH2. This is hydrogen. The same way here, H2N, NH2 combined with the weakly acidic medium. What happened here? Aldehydes of hydrazone, that means aldehydes hydrazone, you may get it. So what is it, aldehydes hydrazone? Here H2O, the water, elimination of water. So removal of water, what you will get it? C double bond, here H, C double bond N, NH2. So this is actually what it is, hydrozones of aldehyde. The same way here also, elimination of water molecules. So that means what it is, C double bond here. Hydrogen won't be coming here. Methyl group both the side. C double bond N, NH2. So aldehydes of hydrazone or ketone of hydrazone, you may get it. Okay, now in this question, why do we use weakly acidic? Why can't we use strongly acidic? That is the question. Yes, let us go for it. What happened when we use weakly acidic means, now this is C double bond O, H combined with H plus ion. Okay, so what happened here? Oxygen goes towards the proton, you will get carbonyl protonate, protonated carbonyl group, you will get it. So the positive charge on carbon. So this is actually what it is. It acts as a nucleophile. So this nucleophile formation will attack the hydrazine. So you will get that hydrozones of aldehydes, neither ketones, you will get it. Suppose if this is actually what it is, weakly acidic medium, weakly acidic medium. Okay, now suppose if we are using strongly acidic medium, what will happen? The strongly acidic medium, directly it will react with hydrazine. That hydrazine is actually a basic in nature. Now I just mentioned here H2N, NH2. So this is actually basic in nature. So it reacts with strongly what it is, acidic medium. This is a strongly acidic medium. Strongly acidic medium. Okay, so what happened if it reacts? So this is actually what it is, a basic in nature. So the strongly acidic medium react with the hydrazine. So directly you will get what it is, salt formation. The salt formation will not react as a nucleophile. Here this formation acts as a nucleophile. This will go and attack the hydrazine H2N, NH2. So this will go and attack as a nucleophile and form the hydrozones of acetaldehyde or hydrozones of ketone, you will get it. Whereas here strongly acidic medium, if you are using, this strongly acidic medium will react with the hydrogen because it is a basic in nature. So it reacts with the hydrogen. You will get that salt formation H2N, NH3, salt formation. So this is not acts as a nucleophile. So this is not acts as a nucleophile, means it cannot get that attack of that what it is, hydrazine. Okay, hope you're clear. That is the question. Hydrozones of acetaldehyde are not prepared in highly acidic medium. Why? This formation cannot act as a nucleophile, whereas weakly acidic medium, if we are going, this formation acts as a nucleophile and that will attack the hydrazine. Hope you're clear with this question. The next question, oximes are more acidic than hydroxylamine. So oximes are more acidic. Why? Let us go for that. If actually this question, it says about difference between, also we can say to that. Okay, now let us go for that oxime. This is oxime and this is hydroxylamine. hydroxylamine. Yes, okay. Now, as we are writing the formula, so oxime lose the proton and form that conjugate base. How? C double bond O N OH, it's a oxime, and here NH2 OH, it is hydroxylamine. So what happened? It lose the proton both. What happened here? H plus. So what happened? It lose a proton to form conjugate base. So conjugate base, how come it is possible? See double bond O N O minus. Whereas here N H2 O minus. Okay, now this is a conjugate base. Conjugate base. Now here this is also conjugate base. Now what happened here? Resonance stabilized. So here resonance stabilized means here you will get minus charge. Right. Okay. That means here due to that resonance it is stabilized. It is more acidic. Whereas here it is this also conjugate base only, but it does not have the resonance. Resonance is nil. Resonance, it's nil. Okay. Whereas here resonance due to that resonance it is stabilized. Stabilized due to that resonance. Hope you're clear with it. Next question. Next, one more interesting question. Di-tertiary butyl ketone does not give PPT with the sodium bisulfite, whereas acetone does. How is it possible? Yes, let us go for it. This is acetone, double bond O, CH3, here CH3, C double bond O. Okay. Now this reacts with the sodium bisulfite. So what happened here? You will get the crystalline precipitate of addition product. So that means here C, here CH3, here CH3, here OH, here SO3Na. Here salt formation takes place. Yes, addition product. Whereas di-tertiary butyl ketone. So di-tertiary butyl ketone. So this is a ketone. Di-tertiary. So that means two tertiary product will be there. So here CH3, CH3, CH3. The same way here CH3, CH3, here CH3. Okay, is it, why can't, that means di-tertiary butyl ketone does not give PPT with where it will go and react. This is a carbonyl group. So NaHSO3, that the sodium bisulfate cannot go and approach the carbonyl group. Why? Where there is a gate to approach. Here a steric hindrance, a group of soldiers are available inside only the carbonyl group it is there. So how is it possible this what it is compound can approach the carbonyl group? So carbonyl group it's there inside that. Okay, so both this side what it is steric hindrance like soldiers they are, so it cannot react with it because what it is due to that steric hindrance. That's all. Why it cannot, this sodium bisulfite cannot approach the carbonyl group due to that steric hindrance. That's all. Hope you're clear with this very simple and very interesting question. Hope you understand. Whereas here acetone, it gives that crystalline precipitate of addition product of the sodium bisulfite. Here, see now what happened, what is the product? I hope you got that idea. But whereas here you can't. Why? Because this cannot go and approach the carbonyl group due to that steric hindrance. Hope you're clear. Next, one more interesting question. Dialkyl cadmium is considered superior to Grignard reagent for the preparation of ketone from an acid chloride. Why? It's like comparison question. Okay, give reason, comparison, such kind of question. Let us go for the first one. Dialkyl. Dialkyl cadmium. Okay, dialkyl cadmium actually it is a less electropositive positive. So acid chloride, from an acid chloride only they mentioned C double bond O Cl. Acid chloride combined with R2 CD, dialkyl cadmium. Okay, now what happened? This acid converted into further, you will get what it is, ketone only. So directly you will get it C double bond O R. So here what happened? R CD Cl it releases. Yes, it's dialkyl cadmium. It's a superior, directly you are getting ketone. Whereas Grignard reagent, what happens? So Grignard reagent. So here, Grignard reagent, the same acid chloride double bond Cl combined with RMgX. What is it, RMgX? Alkyl magnesium halide. So what happened here? You will get acid chloride. That is actually what it is. You will get that ketone compound also, and further oxidized with what it is, tertiary butyl alcohol. Also it is possible. So the two products it's possible. Whereas here cadmium, it is a less electropositive. It reduces acid to ketone. At ketone it is very less reactive, further it cannot go and give the next product. Okay, so that's all the point. Okay, now here what happened here, R C, here O M G X, here Cl, here this R which will go and join. Okay, now what happened here? So this OMGX, so here what happened, the Cl also, here again R C double bond O, here R, this thing it will go and attach with it. So further it reacts with what it is, H plus H2O hydrolyzed and RMgX. So what happened here? Tertiary alcohol formation. Here OH, here R, and then here one more R. So here tertiary alcohol formation, you will get it. Here ketone also you will get it, and here you will get tertiary butyl alcohol also, further oxidize that ketone, further oxidizes, again you are getting what it is, tertiary butyl alcohol formation it is getting. But here dialkyl cadmium, directly it gives ketone, further it cannot react. Why? Because it is less reactive, and cadmium it is less electropositive. That is the reason. Hope you're clear with this. Next, one more interesting question. What is the function of Rochelle salt in Fehling solution? It's very really interesting question. Come on, let us go for it. Fehling solution means A and B will be there. What is it? A, it's a CuSO4. Okay, so it's a blue in color. And B, it is what it is, CHCOONA. Here CHOHCOONA. Here CHOH COOK. Sodium, potassium tartrate. Sodium potassium tartrate only. So what is it also known as? Rochelle salt. That's what purposely I have written there. Rochelle salt is also known as sodium potassium tartrate, is also known as Fehling solution B, and this is the formula. Okay, now what is the function? How to identify? Now CuSO4 combined with the sodium hydroxide. What happened? You will get what it is, CuOH twice plus Na2SO4 you are getting. Okay, CuOH twice, actually it's a precipitate. So to keep it in alkaline medium solution, we are adding Fehling solution B. Okay, CuOH twice, isn't it? I just put it in this way. Then we are adding what it is. Rochelle salt is also known as Fehling B. It's a colorless. It's a colorless. But this one it's a color. So we are adding here CHOH COONA, and here CHOH COOK. Right. Now, what happened? Water removal, elimination of water. So, what is the product you are getting? You are getting the salt formation of Cu, here O, here O. Here what it is? CH, COO, Na and CH, So here actually you are getting this kind of formation. You will get a deep blue color. Deep blue. Okay, now why do we get this deep blue color? This is actually because of that Fehling solution A. It is imported for the deep blue color to keep that what it is Cu2 plus ion. Right? Okay, now next one. Suppose if we are adding with what it is RCHO, you will get what it is red PPT Cu2O plus RCOOH. Acid formation, you will get it, and you will get what it is red PPT. This is what it is red PPT. You will get it. Now you are getting the product which is deep blue color. So which is importing that color means filling solution A. Due to the filling solution A only, that salt has become deep blue color. Okay, the other point, Rochelle salt is also known as sodium potassium tartrate, I mentioned, and this is the formula, and this acts as, it serves as a chelating agent. This is chelating agent. Okay. Why? Because CuSO4 combined with the sodium hydroxide, you will get CuOH twice, acts as a precipitate which is insoluble. To make it soluble, to make it an alkaline medium solution, we are adding this, what it is, sodium potassium tartrate. So we are adding, so when we are adding, what happened? Removal of water, you are getting that salt which is a deep blue colors. So deep blue color, to whom it is getting, that is because of A, it is imported to that B. Suppose if we are adding aldehyde converted into acid, and that is RCOOH I mentioned. Okay, now in that Cu2 plus ion, it's a red PPT. So please note down, this is the what it is function of Rochelle salt. Hope you're clear with it. What is the function of Rochelle salt? What it acts as a Rochelle salt? It is a chelating agent. Hope you're clear with this question. The next one more interesting question. Aldehydes usually do not form stable hydrates, but chloral normally exist. Chloral hydrate, explain. Generally, aldehyde reacts with water. It's a reversible reaction. It is actually product which will be unstable. The hydrates of aldehydes of hydrates, it is actually unstable. So again, it equilibrium shift backwards to that original reactant only. So now R C double bond O H. This is a aldehyde formation combined with water. You are getting what it is. It's a reversible reaction only. So R C, here H, here OH, here OH. Again it come back to that original position only. It's an unstable product. Okay. Now the next one, whereas chloral C, here Cl, here Cl, here Cl, here C, double bond O, here H. Okay, so these are all having, actually this is a chloral. Chloral combined with water, what happened? Actually, this chloron is having what it is, the presence of three electron withdrawing group, it is there. Electron withdrawing group. Due to that electron withdrawing group, the positive charge increases on carbonyl carbon. Carbonyl carbon. Positive charge, slowly it increases. So, water acts as a nucleophile. It is acts as a nucleophile and form that what it is, chloral hydrate, which is very stable and cyclic formation, it is taking place. Okay, what is that cyclic formation? Now let us go for it. This is Cl, this is Cl, and this is Cl. Here CH, and here one hydrogen, here one hydrogen. These both combined with this oxygen, and these both combined with this oxygen. So this is a chloral hydrate which is more stable than this. So that is what they mentioned. Chloral normally exists chloral hydrate, whereas aldehyde do not form a stable. This is not a stable. This is a irreversible reaction. This is a irreversible reaction, but this is actually what it is due to the presence of electron withdrawing group of this chlorine atoms. So carbonyl carbon is having what it is positive charge increases on carbonyl carbon. So you are getting the stable formation of chloral hydrate. Hope you're clear with this. The next one more interesting question. Treatment of benzaldehyde with HCN gives a mixture of two isomers. That means they are giving the two product only. So which cannot, the two products also you cannot separate it by even very careful fractional distillation. Generally, two compounds means easily we can separate by fractional distillation, but even careful fractional distillation also we cannot separate. So what are they? What is the name of it? They are asking. Okay, now benzaldehyde reacts with HCN. You are getting what it is, benzaldehyde cyanohydrin. That's all. C6H5 CHO combined with the HCN. You are getting C6H5 C hydrogen, here OH, here yeah, I just put it here CN, here OH. Okay, and the mirror image of another one, the same way C hydrogen, here CN, here OH, and here C6H5. Okay, mirror image, same molecular formula but different structural formula. Like what is it? Functional group attached in a different. Because why, this is actually asymmetric carbon introduced. Because of that asymmetric carbon introduced, you are getting what it is, dextro and levo rotatory formation of isomer you are getting. Okay, now what are they? Means they are enantiomers. Enantiomers. Okay, enantiomers means what it is? Two forms of mirror image. This is actually a mirror. Okay, mirror. Two forms of mirror image that cannot be superimposed. What is it to superimposed? Okay, now this is one formation of molecule. This is another formation of molecule. Both are, we are getting the different kinds. So we cannot say, we cannot keep it as a same. It is a superimposed, cannot be superimposed. Superimposed means like this, cannot be superimposed like this. So the enantiomers we cannot separate easily by fractional distillation. That is what they mentioned. Hope you're clear with that. What is enantiomers? Cannot be superimposed on one upon the other. So in that way we can identify enantiomers. Okay, in some other session we will discuss about that full isomers or stereochemistry complete idea. We will go for it because there are some more questions will be available for that mirror image, enantiomers, chelating, all those questions will be available. So we'll go for one special session only. Okay, hope you're clear with this one. Benzaldehyde cyanohydrin, that is dextrorotatory, levorotatory. Why do we get it? Because of it asymmetric carbon which is available. Hope you're clear. The next question, it is really puzzle. A ketone A undergoes haloform reaction, gives compound B on reduction. So compound B on reduction, what it is? A ketone gives that B while reduction time only. So the B on heating with concentrated H2SO4 gives compound. That means removal of water. So here on C, which forms a mono ozonide, ozone formation. Ozone formation is the clue for us. So that is D. D on hydrolysis with zinc dust. Yes, of course. We will get what it is, only acetaldehyde. These are the two clues for us. Okay, one it is ozonide formation. That means ozone will be there. The second one, acetaldehyde. Acetaldehyde formation means we can go for carbon 4 compound. Okay, so carbon 4 compound means let us go for the butanone CH3, C double bond O, CH2, CH3. Yes, let us go for it because acetaldehyde only is that final product. Let us go for it. This undergoes reduction. See, in this halo forms they mentioned. Let us go for the last point, halo forms. Why? Because from this we are checking whether it is correct or not from this clue. Okay, now B on reduction. So this is A. Okay, now B on reduction, what it is? CH3, CHOH, CH2, CH3. See, usually ketone undergoes reduction, you will get iso formation only. No, that means iso butyl alcohol only, you will get it. Okay, fine. So the ketone undergoes with that reduction point, you are getting isobutyl alcohol. Okay, isobutyl alcohol reacts with what it is? B on heating with what it is? Concentrated H2SO4. So concentrated H2SO4 while heating, what will happen? Water relieving only. Water relieving means just let us put it here. CH1 hydrogen will come. Let it come down. So automatically water removal CH2, no, right? Okay, now write we CH3 CH double bond CH. Okay, CH3. Yes, alkene formation, alcohol converted into alkene formation due to the removal of water. Yes, okay. Now again, this compound C, this is compound A, this is compound B, and this is compound C, and this compound C which forms monoozonide. Yes, that means it will react with ozone. So what you will get it? Please remember this is ketone, butanone. Okay. Okay, now here what you will get it? CH3. C, that bond breaks, no, ozone comes means CH. Here CH. I just rub this side. So this it will be easy for you. Both connected with 3O is there, no? Cyclic compound ozonide. Here CH3. The same thing only, here double bond breaks. In this point, ozone formation takes place here. Ozone 1, 2, 3. This is because of O3. Yes. Okay. Now, what happened here? This reacts hydrolysis. What is it? Hydrolysis in the presence of zinc dust. Already I mentioned in my video what happened with why do we add zinc. I just mentioned in my video. I will put it in that description box. Please watch it. Okay, now what happened here? The ring, you just break it, so automatically you will get CH3 CHO, CH3 CHO. So that means two molecules of CH3 CHO. Yes, we got it, acetaldehyde. We want that only, no, acetaldehyde. Identify A B C D. So that this is this compound D, acetaldehyde formation. So this is compound D. D on hydrolysis, we are getting acetaldehyde. This is acetaldehyde. Acetaldehyde. Hope you're clear with this. It's so simple. Let us go for that each one. Okay, now we finalized this only, is it? Now we are going for the halo form. Halo form is nothing. This what it is, butanol combined with iodine along with NaOH. You are getting CHI3. That is what. Okay, let me write it that one. Hope you're clear with this. Okay, let us go. I'll rub them. Now this butanol CH3CO CH2 CH3. Yes, 1, 2, 3, 4. Okay, now reacts with iodine along with alkali, that is NaOH. You are getting what it is? Halo form. Yes, they have mentioned that only, no, halo forms. Okay, now why do we go in this way means because this too close, actually it has given that idea acetaldehyde only, because acetaldehyde where it is C with double bond O connected with which position, that is very important. Okay, so acetaldehyde means naturally this point only you will get it. Okay, now the second one clue, it is what it is, reduction point they mentioned. Reduction point means naturally it is isobutyl alcohol. In that way we can recognize it. So this is that haloforms reaction. Okay, now they mentioned that, write down that reaction involved. Yes, identify A, B, C, D. You have to write the answer. You have to bring all that equations along with that. What are the compounds? You have to mention the name here. What is it? A, B, C, D. I just mentioned A. It is what it is, butanone. Then B, it is isobutyl alcohol. Third one, it is butene, and then fourth one, it is ozonide formation of butene. Okay, hope you're clear with this idea. Please take that screenshot if you want. Hope you understand very clearly. Thanks for watching and thanks for your great support.